we have successfully converted the byte slice into a string slice. Now let's figure out how are we going to parse its contents. Here on top we have the example request. So we pretty much want to extract the method, then the path and the query string, and then the protocol. We need a way to explode this string on spaces and read it word by word. Let's do that by writing a helper function. We can call it get next word. And how would such a function look like? It will it will accept our request, which is a string slice, and it will return, I guess, another string slice because it will just return the next word. And let's add an unimplemented macro so the compiler doesn't complain. This signature would be fine if we want to get only the first word from our request, but we want to be able to call this function multiple times and every time get the next word. So the first time we call it, we want to get the method. The second time we call it, we want to get the path. And the third time we call it, we want to get the protocol. So this means that somehow we have to remember how far along are we in the string. So then in the next call, we can start from there. To do this, we can actually return a tuple here with two string slices. The first one will be the word that we want. So when we start, this will just contain the method, for example, and the second one will be the rest of the string. So it will contain all of this. And then the second time we call the function, we pass the rest of the string as a parameter, and this will return the first word and then the rest of the string. Okay, we solved that problem, but now there is another problem. What would happen if there are no words in the string? What would happen if we have a request that doesn't have spaces in it? Then what are we going to return? As we know, in Rust we don't have a no type, so we can't just return no, but we can return none. That means that we have to wrap our result in an option, and that way we will actually be able to return nothing if there is no next word in the string. Now for the implementation, we will have to loop through the string until we find the space. To loop through the characters of a string slice, we have to actually call the chars method on the string slice. This method will return an iterator over the characters of the string slice. An iterator in Rust is very similar to iterators from other languages. It is just a struct with a method called next. Every time we call next, we will get back an option. This option will either contain the next element or it will be none, which means that we have exhausted the iterator and there are no more elements. This means that we can use this iterator in a loop. So if we actually assign the iterator to a variable, and now we can write an infinite loop. In here, we want to get the next item from the iterator by calling the next method on the iterator. This will return an option, as we can see. So we have to match on this option. So we want to match on item. And if it is sum, then in our case, it will contain the next character. Let's call this C. And we leave the body for later. Otherwise, if it is none, this means that there is no space. And in this case, we want to break. Okay, now the compiler still complains because we are not returning anything from the function. But if we ignore that error, this is one way in which we might be using iterators. But this is very clumsy and it is a lot of code for something simple. Luckily for us, Rust also supports for loops, like any other language in the world pretty much. And for loops are technically just some syntactic sugar for working with iterators. We can rewrite this code using a for loop, using the syntax for, let's say, C, which will be our character, in request.chars. And this is pretty much it. Now this code will loop through all the elements in this iterator, which in this case are all the characters in our string slice, and it will assign them to the C variable here. We can use the C variable in the scope of the for loop. So first let's get rid of all of this unnecessary code. And one thing to note here is that we only get the element, but we don't get its index inside of the string. And for our case, we would actually need the index because we will have to split this string in two. And we will do this at the current index of the space that we find. To get the index when using an iterator, we can call the enumerate method on this iterator, and this will actually give us another iterator that yields a tuple on every iteration. And this tuple has two elements. The first one is the index and the second one is the value. So we can rewrite this to actually export this tuple. And now we have our index. In the body of the loop, we want to compare the C variable with space. So we can say that if C is equal to the space character, we want to return sum wrapping a tuple with two string slices. Okay, we know that the first string slice will be the word that we want. So for this, we can just say that we want our request and we want to get all of the characters until the index I, which is our current index, and that's the index of the space. So this will be all of the characters before the space. And now here we have to, I guess, put everything after the I. But there is a small problem with this. If we write it like that, the lower bound of this range syntax is inclusive, which means that the space will be a part of the return value. And we really don't want to include this space in our result, because in the next iteration, when we pass this as the parameter, it will just look at the first character, it will see that it's a space, and then it will return an empty first word. So to skip the space, we can just add 1 to this index. First, to make sure that the compiler stops complaining, let's return a none here at the bottom. And now let's actually focus on what we are doing here. Remember when we were discussing strings that we said that this is very, very dangerous, just adding row indexes when using a range over a string can lead to a crash of our program. The reason for this is that all strings in Rust have to be valid UTF-8 encoded. And by adding 1 here, this does not mean that we are adding 1 character, we're adding 1 byte. So if the next character in this string is longer than 1 byte, it's for example an emoji or a Cyrillic letter, this would lead to generating an invalid UTF-8 string, and eventually our program will crash. In this case though, we know that the character at the index I is a space, and we know that a space is 1 byte long. So when we add 1 byte, we are effectively only skipping this character, and we know that we're skipping the whole character. So this code is actually safe.